In this video, we're going to go over factoring. In the previous video, we went over expanding. So let's review expanding very quickly. Expanding, you would have two expressions such as x plus 2 times x plus 4. And if you've been practicing this, you can go straight to 2x, 4x, so that's 6x plus 8, 2 times 4. Now, a slightly harder one would be 2x minus 7 squared. So the beginner version would be, you might first need to write it out so you can visualize it, and then do 1, 2, 3, 4. But let's do the advanced version. So if you feel this is too scary, that just means you have to go back and practice a lot more of that. So notice this is something minus something squared, and from the previous video there were 3 things that I asked you guys to memorize, and one of them was this one. So this looks like the same shape. So there's something minus something, x minus y, squared. And the recipe is square the first thing minus double the product of these plus this thing squared. So using this recipe, we're going to do this in our heads. So that means we square the first term, so that's 4x squared. Don't forget to square both the 2 and the x. Some people say 4x, some people write just 2x squared. It's both 2 squared and x squared. Alright, now minus double, so double this product, so 2x times negative 7 is negative 14x, double that, so minus 28x plus 49. Now, if you weren't able to do this, that means you haven't learned this recipe very well. Once you learn this recipe, you're going to apply this, except now your x is going to be 2x and your y is 7. So focus on how we get this. Alright, so that's expanding. Now, for factoring, all we're doing is going backwards. So you would be given the right side, and I would ask what times what, which 2 expressions of this shape can get you to here. So if I gave you x squared plus 6x plus 8 and I say factor this, then I would want to see x plus 2 times x plus 4. So I actually find factoring a lot more fun because it's kind of like a game. But before we get into that, what's the point of this? Why are we even factoring in the first place? So let's say we have x squared plus 6x plus 8. That's fine, but let's tie this back into our basic algebra. So in basic algebra, we had stuff like 2x plus 4 is 7, and we could solve this by moving the 4 over and dividing by 2. So the way this comes into play oftentimes is we're given a value for this. Or let's take this expression, which is just another polynomial, which just means expression with a lot of powers. And let's say we're not just going to be given this, we're going to be given this equals a number such as 0. Or let's say it's not 0 if it's, let's say this is 5 and that's 2. Then our strategy will be to make this 0. So that means we're just going to move the 2 over and go back to our original one with 3. Alright, so we don't want to basically just factor this thing. Traditionally we'll be given a problem with some expression equal to a number. Now, unlike in our easy algebra, here you know how to do this. If I said solve for x over here, it looks kind of difficult because I think of this sort of as Siamese twins. You have the x squared and you have the 4x. If we get rid of this one, you can solve for x. That's pretty simple. If we get rid of this one, that's not too bad. You can move the 3 over and take the square root to solve for this one. But now we have both of these, so any time you try to do something to one of them, the Siamese twin sort of messes you up. So it's not clear how to approach this. However, with factoring, we could see if we could find 2 things and set them equal to 0, then we could get our original basic algebra, linear, simple expressions. So these are both x's because x times x is x squared. Then we play a game of which 2 numbers multiplied are 3 and added are 4. So as you could probably tell, if we do 1 and 3, 1 times 3 is 3, 1 plus 3 is 4. So that means that this expression times this one will get you this whole thing. Now why is this better than this? Because we have a number times a number is 0, which can happen only when one of them is 0. So either this is 0 or that's 0. So we solve this one, and notice this is very easy to solve. So we get x can be -1 or -3. And if you plug these in, that would be +1 -4, -3, +3 is 0. That would work as well. It's very hard to just guess these numbers. Maybe you can guess this one. This will be a little trickier to see. So that's the benefit of factoring. When you have something that's quadratic and crazy looking, if you can find a way to break it down, then you could solve these very simply. Now, this is going to tie into quadratic equations because we're not always going to be able to break this down into really nice numbers like 1 and 3. This could be square root of 7. So in the general case, you might not be able to see how to do this, and we're going to develop our solutions to that later when we go over the general case. So don't worry about that. For now, we're going to assume that whatever you're given here will be very nicely broken down to easy numbers. So the skill we're drilling here is given something of this sort. How do we factor it into two parts? So let's say I gave you x squared plus 6x plus 8 just by itself or equal to 0, and then you could say, okay, these are both x's, that's the way we're always going to start these. Which two numbers multiplied give you 8 and added give you 6? So that would be 2 and 4. And from here we could tell that x has to be -2 to make this 0, or x has to be -4 to make this 0. So that would be the actual full application. We don't want to just factor it. We're doing this so that we can actually find these x values. But for the rest of this, I'll ignore the setting it equal to 0, but know that ultimately that's where we're going. So we're just going to drill this with a few problems. And in the next video, we'll just go over practice problems.